Hello, my name is Steve Carniato, and I'd like to welcome you to the presentation of the preliminary design review for Team 13, Project 56, Quality Control using Timing Analysis. Our project is sponsored by Chinmay Trivedi of VMware. So, quality control using timing analysis is a bit of a mouthful, but in our case, what it boils down to is the analysis of test logs using machine learning algorithms that we're going to implement in software to detect deviations from expected timing of different tasks in the test phase. Um, we've developed some key requirements to go with. The first of which is that our software will detect when a new log has been created. It will then automatically begin to analyze the log, looking for those typical deviations in the timing. From there, it will store the results in a database so that they can be used later for further analysis, and also they need to be used for further training of the machine learning algorithm. This is key so that the machine learns over time what are the characteristics to look for and what are the deviations of those characteristics. The final portion will be to notify a user if an anomaly is detected during the analysis phase.
My name is Elijah Haddam, and I'll be doing the design and architecture section of this presentation. As you can see from this slide, we've split this project up into 5 different modules, each performing a critical piece of the puzzle for this project. The first is the data parsing module. This is where the build log file will actually be passed in, and the module will parse, essentially crawl through the log file, grabbing the relevant data that we need to perform analysis on it. The data analysis module takes the data from the log parser module and as well as memory from the database, which flows from the third module, the analysis results storage, and essentially looks at the data that was collected from the parser module, compares it with previous results, and says, okay, is this different? Is this anomalous compared to our previous builds? And then based off of that, it'll send send instructions to the email notification module, instructing it that, hey, there was an anomalous build, send out to the appropriate people that and to notify them that there was something that didn't seem quite right or seemed different with this particular build. The last one I'm going to go over is the UI module. This is kind of a bonus that we'd like to implement. It's just a simple user interface that allows a user to go on, give it build files explicitly, and to be able to look at what the anomalies were. So it should provide a list of the anomalies that have been recorded by the analysis engine.
Hello, this is Frank Levesque, and I'm going to be talking about the implementation strategy for our project. If you break down our project, we have 6 different areas, 2 of which are documentation, and the other 4 are modules we have planned. Most important this semester is the parser and analysis modules, which extract and then process information from log files. In weeks 9 to 12, we will be doing research on machine learning. That's an interesting topic. Then we will begin the parser module, and in weeks 12 to 14 we will finish that parser module and start the analysis module, and then semester 2 starts. In the beginning of semester 2, weeks 1 through 3, we have completed the analysis modules, and then we start the final 2 modules. The UI module, which will display information in a visual form to the user, and an email notification module, which will send messages depending on what's needed to the user. In weeks 3 to 10, we will complete those 2, and the last few weeks, we will be testing and refactoring everything to make sure all the modules work correctly.
Hey, this is Ron Miller, and I'm going to be going over the process portion of the presentation. We're going to be using an agile approach and a web-based tool called Asana. It relies on kind of a Scrum / Kanban background. We'll be utilizing the board. We're going to set up our own columns. And what's actually displayed here isn't our board, just because we do not have all of the backlog items yet. We're still kind of researching. And so once that's populated, it will look very similar to this. We call it hybrid Scrum Kanban because we're not going to have the true daily stand-ups and the retrospective and the planning. We're going to have to approach it a little more flexible than that, just due to the various time zones. We're a remote team. We can't get in alignment every day for a 15-minute meeting. We will have 2 meetings via Google Hangout every week where we will discuss objectives, obstacles, and accomplishments. This isn't intended to be a status meeting. It's really like a football huddle. We just want to get out the key information and start executing. Additional communication, we'll be using a Slack channel. It's a collaboration tool. It's really intuitive. Our project sponsor is on our channel and has been communicating with us, and so that gives us the flexibility of not being able to meet at the exact same time. Our artifacts will be managed through Google Team Drive. This was a discussion that occurred with our sponsor and team, and we decided to move away from the Microsoft Suite, and that the Google Team Drive would be a better option for all of us. Our project sponsor does participate in one weekly Google Hangout, and we work through many project items as well as kind of our user stories and how he views the execution of that and if it meets his standards.
My name is Sam Nixon, and I'm going to be covering the risk management portion. Our team came up with 2 types or classes of risk. The first type that we identified were team dynamic risks. Included in this type was the inability to build optimal cohesion due to having a remote team, our lack of co-location, the delays in communication due to having a remote team, the conflicting priorities of the team members, and the fact that our individual schedules may not align because we live in different time zones. And the second type of risk class that we identified were technical risks. One of the main technical risks was the lack of technical knowledge of machine learning. A large portion of our project is related to machine learning. There is additionally a lack of depth of the programming language Python. Most of our previous experience has been in Java or C++. Furthermore, there's a lack of real-world development experience. Most of our development experience has been in an academic setting. And finally, we have a limited time to acquire the necessary skills to succeed.